All right, so we're going to talk about recipes today. So, who's hungry just thinking about recipes? I know I am. But we'll talk about recipes just to kind of wrap our minds around ratios a little better. So today, our learning targets are I can explain the meaning of equivalent ratios using a recipe as an example. I can use a diagram to represent a recipe, a double batch and a triple batch of a recipe. I know what it means to double or triple a recipe. So first, for our little warm-up activity, this is a flower. It's made up of yellow hexagons, red trapezoids, and green triangles. So hexagon is a shape with 6 sides. The trapezoid you can see there in the middle of the flower. It looks like a sunflower kind of, I think. Isn't that what sunflowers look like? Yeah. All right, so we're going to write a sentence. Well, we're not going to write it. We can just talk about it out loud to describe the ratios of the shapes that make up this flower. So again, we've got the yellow or golden hexagons. We've got the red trapezoids in the middle, and then the green triangles make up the stem of the flower. So if we were to talk about the ratio of yellow hexagons to green triangles. Let's talk that out. How many yellow hexagons do we have?
Six.
6. That's right. And how many of those little green triangles do we have?
Nine.
9. That's right. So if I were to ask you what is the ratio of yellow hexagons to green triangles, what would that be? Can you tell me? If we know we have 6 yellow hexagons,
69.
6 to 9. That's right. Awesome job. Let's do one more. We'll do the red trapezoids to the yellow hexagon. So, how many of the red trapezoids do we have?
Two.
2. That's right. And how many of the yellow hexagons do we have again?
6.
6. That's right. So, if I were to ask you what is the ratio of red trapezoids to yellow hexagons, what would that be? How many red trapezoids do we have for every one of those hexagons? So what is the ratio of trapezoids to hexagons?
6 to 6.
2 to 6, right. So remember, if you're asked a question about ratio, the first category, the number of the first category goes first, and the number of the second category goes second. So if I was asking you trapezoids to hexagons, the number of trapezoids would go first, and the number of hexagons would go second. So all right, another question. How many of each shape would be in 2 copies of this flower pattern? So if there were 2 flowers up there, how many of the yellow shapes would we have? If there were 2 flowers up there.
12.
12, that's right. What about trapezoids? If there were 2 copies of that flower up there, how many of the red trapezoids would we have?
4.
4, that's right. So going further into the lesson, we'll talk about, and if you remember, one of our learning targets was I can tell what doubling a recipe means. So right there, we were basically talking about doubling the number of those shapes. So let's keep going. All right, so pretend that we've got a powdered drink mix here, like Crystal Light or Kool-Aid or whatever kind of powdered drink mix. They come in the little bitty packets, and you can open them up and pour them in your water. So here we've got a powdered drink mix. So which one of these powdered drink mixes? So we've got powdered drink mix A, powdered drink mix B. In powdered drink mix A, I'm going to say powdered drink mix a lot, so I'm sorry. In powdered drink mix A, we've got 1 teaspoon of the powdered drink mix, which you see is the little white square. And then we have 1 cup of water, which is the big blue square. So in our powdered drink mix B, we've got 4 teaspoons of the mix and 1 cup of water. So if you were to think about making these drinks out of these mixes right here, one A being 1 teaspoon of the mix and 1 cup of water, B being 4 teaspoons of the mix and 1 cup of water, which one do you think would have the strongest flavor? So if we're putting more of the mix in drink B, do you think it would be stronger than just putting 1 packet of the mix in drink A? Huh?
Yes.
Yeah, B, because we've got a lot more powdered drink mix in our drink B than we do in A, right? So it'll probably be stronger. So if we wanted to make them equal, how could we make mixture A or drink A taste like drink B? How do you think?
That's close.
So you think we just add more drink mix to A?
Yes.
That's right. So right now, A only has 1 packet of the mix. B has 4 packets. So if we wanted them to taste the same, we would just add 3 more packets to drink A, and then they would taste exactly the same. Nice job. Okay, so we're going to describe the ratio of ingredients here that we see. So in container A that we see here now, what is the ratio of the powdered drink mix to cups of water? Can you tell me? Remember, the white squares are the drink mix and the blue square is the cup of water. So what's the ratio of drink mix to water in container A?
4:1.
4:1, exactly right. Nice job. What about B? What if I were to ask you what the ratio of powdered mix to water was?
4:1.
4:1. So how do you think those two drinks are going to taste? Do we have the same amount of ingredients?
Same.
They will taste exactly the same. That's right. So let me ask you this. What if I pour all of those contents into one large container and we'll label it container C, and then we mix them all together? How do you think the mixture in container C would taste? You think it would taste the same as A and B? Think about making Kool-Aid.
Different and the same.
Different and the same. Think about making some Kool-Aid. If we make one batch of Kool-Aid in container A with 4 packets of the drink mix and 1 cup of water, we make another container of Kool-Aid with the exact same ingredients and we pour them together, you think they're going to taste the same?
They're not the same.
They probably will taste the same. That's right. So what they're trying to get you to see here is that if we've got 2 recipes with the exact same ingredients and we put them together or we double them, that means we're putting 2 batches together of a recipe. That means we're doubling them and they will taste exactly the same, just like it would be if we were making Kool-Aid. I haven't had Kool-Aid in forever, by the way, and it's delicious. All right, so let's look at this one again. We're going to look at another one. So we've got the containers that we just talked about. We've got container A with 4 teaspoons of drink mix and 1 cup of water. We've got container B with the exact same ingredients. And then container C that we see there shows us what would happen if we were to combine them. We would have 8 teaspoons of drink mix and 2 cups of water. So what did we do there when we added the 2 together? What's that called? If we're adding 2 batches of the same recipe together, what is that called? We just talked about it. Can you tell me?
I don't have that.
It's okay. It means that we're doubling the recipe. So if we've got one recipe with ingredients in it, we've got a second recipe with the exact same ingredients in it, and then we pour them all together, we're just doubling that recipe. Okay? So let's complete these sentences here in number 2. We've already talked about number 1. How would the taste of A compare to the taste of B? We said those will taste exactly the same. So in number 2, under the first statement, mixture B uses blank cups of water and blank teaspoons of drink mix. How many cups of water does mixture B use? You remember the 1, right. So how many teaspoons of drink mix does mixture B use? 4. Good job. So the ratio of cups of water to teaspoons of drink mix in mixture B is what? Can you tell me? So our first category is cups of water. We know we have 1 of those. Our second category is teaspoons of drink mix, and we know we have 4 of those. So what would our ratio of water to drink mix be?
1 to 4.
1 to 4, perfect. All right, so mixture C, that's where we combined all of our ingredients from A and B, or we doubled the ingredients. It uses how many cups of water?
2.
2, that's right. How many teaspoons of drink mix?
8.
8. Awesome. So what would our ratio of water to drink mix be in our mixture C that we have there?
2 to 8.
2 to 8. Perfect. Awesome job. So how do you think those are going to taste? How do you think B will taste compared to mixture C? We talked about it just a minute ago.
And the same.
Exactly the same, because all we're doing, we have the same ingredients, we're just doubling it. Good job. All right, so now we're going to talk about cookies, and if you want to get really hungry, we'll talk about some cookies. So let's say we're planning to make some cookies. We're going to use our favorite recipe, which we've got there. They've told us what our favorite recipe is. And we're going to double that recipe. What does it mean to double it? What would the recipe be there if we were to double it? Right now, we've got 1 batch of cookies, and it calls for 5 cups of flour and 2 teaspoons of vanilla. If we were going to double that and we were going to make 2 batches of cookies, what would our recipe look like?
1 to 2.
1 to 2?
Yes. 2.
All right, let's look at it together.
10.
10 to 4. So if we were doubling, remember, we're just multiplying it by 2. Okay? We need to remember, if we double a recipe, we need to double the amount of every ingredient. So if we were going to double the amount of ingredients in our original recipe, which is 5 cups of flour and 2 teaspoons of vanilla, we need to double the flour and double the vanilla. So if we were to double the cups of flour, right now we have 5, we multiply that times 2, and that gives us 10 cups of flour. If we were to double the amount of vanilla, right now we have 2 teaspoons of vanilla. We multiply that by 2, and that gives us 4 teaspoons of vanilla. Okay, so if we've got one recipe and we double it, what do we need to do with that recipe? Can you tell me?
10 to 4.
10 to 4, so we need to multiply every ingredient by 2. All right, so think about it. If we had to add eggs to our cookies, if we had 3 eggs and we needed to double that, how many eggs would we have?
6.
6, that's right. And what if we had to add 2 tablespoons of sugar, which may be a lot for cookies. I haven't made cookies in a while. But if we had 2 tablespoons of sugar and we need to double that amount, how many tablespoons of sugar would we need?
8.
8 tablespoons, that's right. And what if we had to add 2 tablespoons of sugar, which may be a lot for cookies. I haven't made cookies in a while. But if we had 2 tablespoons of sugar and we need to double that amount, how many tablespoons of sugar would we need? 4, that's right. So let's take it a step further. What if we had to triple the amount of ingredients in our cookies? So if we had to triple the amount, say, well, let's go back to our original recipe of 5 cups of flour and 2 teaspoons of vanilla. If we needed to triple that recipe, we would need to triple the amount of every ingredient in the recipe. So what do you think the triple amount of flour would be if we had to triple the recipe that we've got? Do you know what triple means?
15.
15, that's right. So how did we get there? If we triple something, we know we need to multiply it by 3. So in our recipe that we've got here, we know we've got 5 cups of flour. If we needed to triple that, we would have 15 cups of flour. How many teaspoons of vanilla do you think we would have if we tripled that?
6.
6 teaspoons of vanilla, right. So we know we have to multiply each one of those ingredients by 3. So nice job. All right. So we just talked about this and got ahead of myself. So we know that one batch of cookies calls for 5 cups of flour and 2 teaspoons of vanilla. So how many batches could we make if we had 15 cups of flour and 6 teaspoons of vanilla? What do you think? What's that?
3.
3, that's right. So how did we get there? Well, we used division this time. So if they give us the total number of cups of flour and the total teaspoons of vanilla like they do in this case, then we can just divide our original recipe in there, and that'll tell us how many batches we have. So let's look. This is a diagram that shows us that recipe. So total, if you see the number of the cups of flour in the green squares and the teaspoons of vanilla in the white squares, total in this instance, we have 15 cups of flour and 6 teaspoons of vanilla. So if we were to divide that by 3 and break that out into 3 equal groups, we would see that it takes us back to our original recipe. So we've got in this one, let me see if I can highlight that a little better. So if we were to break this out into equal groups, we would see that in each equal group, we have 5 cups of flour and 2 teaspoons of vanilla, which is our original recipe that we have up there. So if we break it out into equal groups based on that original recipe, that tells us that we can make 3 batches of cookies in this example. I hope that makes a little sense. It might have been a bit confusing. But just remember, if we're doubling a recipe, we're multiplying every ingredient by 2. If we're tripling a recipe, we're multiplying every ingredient by 3. All right, so let's look at one more example. So we're going back to our original recipe of 5 cups of flour and 2 teaspoons of vanilla for our cookies. How much flour and vanilla would we need if we wanted 5 batches of cookies?
You know, 5 of flour.
Yes, that is exactly right. What about the vanilla?
10.
10, that's right. So we would have 25 cups of flour and 10 teaspoons of vanilla. That would make us 5 batches of cookies. That's a lot of cookies. All right, so we've talked about doubling the recipe, tripling the recipe. So going back to our original recipe, 5 cups of flour and 2 teaspoons of vanilla. We know that if we were to double, the ratio, let me back up just a minute. I'm sorry. The ratio of flour to vanilla in our original recipe is 5 to 2. If we were to double that, our ratio of flour to vanilla would be 10 to 4. If we were to triple that, our ratio of flour to vanilla would be 15:6. So again, remember, if we're doubling a recipe, we're just multiplying each and every ingredient by 2. If we're tripling a recipe, we're multiplying each and every ingredient by 3. Now we call these ratios that we just talked about equivalent ratios. So what does that mean? Well, they're equivalent ratios because they describe different numbers of batches of the same recipe. Okay, so let's see if we can find. Oh, I don't have the diagram there. So they're equivalent. Because think about it. We talked about the drink mix. If we've got one recipe, say with a ratio of ingredients of 5:2, and we double that, we've got a ratio of ingredients of 10:4, and we mix them all together, they're going to taste the same. Well, if we were to add another batch of ingredients into that, that would give us a tripling of the recipe. But if we were to mix those all together, they would still taste the same. So equivalent ratios, again, just describes different numbers of batches of the same recipe. Okay. So the first question there, how much flour and vanilla would you need for 5 batches of cookies? Linus said we would need 25 cups of flour and 10 teaspoons of vanilla. Well, that is an equivalent ratio also to the 5:2, the 10:4, and the 15:6 there, because it's just describing another batch of cookies using the exact same recipe. It's just a bigger batch of cookies, and they'll all taste exactly the same. They just have different amounts of ingredients in there. Does that make sense?
Yes.
Okay. I hope so. I may have made it a little more confusing than I needed to. Just remember, one batch of cookies is going to taste the same as 2 batches of cookies. That's going to taste the same as 3 batches of cookies. So the ingredients that we use for each of those batches is going to be exactly the same. So those ratios are called equivalent ratios. All right, so just to sum this up real quick, like we talked about, when we're doubling a recipe, how does the amount of each individual ingredient change? How many does it go up by? Goes up by how much?
2.
2, that's exactly right. So what about when we're tripling a recipe? How does the amount of each individual ingredient change? How much does it go up by?
3.
3, that's correct. So how do the different numbers of batches of the same recipe taste? Remember, what if we've got one batch and then we add another batch with the exact same amount of ingredients? We were doubling it. Would they taste the same?
Yes.
Yes, they taste exactly the same. So remember, let's go back to our Kool-Aid recipe. We've got 4 packets of Kool-Aid mix, 1 cup of water in the first batch. We've got 4 packets of Kool-Aid mix and 1 cup of water in the second batch. If we were to mix those all together, they would taste exactly the same. So again, when we doubled the recipe there, we're just making a larger batch of Kool-Aid, and the ratio of ingredients is called an equivalent ratio. So are there any questions?
Thank you.
No questions. Okay. I am going to, I'll stop sharing. I've got an exit slip ready to post on Google Classroom. Let me see, I've got that pulled up. So let's do this first one together. Let me share that. Linus, can you tell me when that pops up?
Yeah.
All right, so in the first example here, this is the first question on our exit slip. It says Priya makes chocolate milk by mixing 2 cups of milk and 5 tablespoons of cocoa powder. True or false? The diagram below represents 2 batches of her chocolate milk. What do you think? Do you think that's true or false?
True.
True, that's right. Why do we think that? So you see the first shapes that are circled there. That shows 2 cups of milk, which are represented by the large white squares, and it shows 5 tablespoons of cocoa powder, which are represented by the small green squares. So how many white squares do we have, or how many cups of milk in that first diagram?
4.
How many in the first one here? Let me see if I can highlight it for you. Yeah, how many in this one right here? Cups of milk. 2. How many tablespoons of cocoa powder?
5.
5, that's right. What about this one? How many cups of milk in this one?
2.
How many tablespoons of cocoa powder?
5.
5. So are these exactly the same?
So, yes.
Yes, so it does represent 2 batches of her recipe because she's got 1 batch here and then a second batch that's exactly the same. Now, what if we were to put all those together? What would we be doing to that recipe if we were to add this batch to this batch?
Double it.
Doubling it, that's right. Perfect. Okay, so I will post this to our Google Classroom here shortly once our video gets finished uploading. And then you can work on it and let me know if you've got any questions on that. So if you don't have any questions or anything else for me, that's all we've got, and you are free to go.